老师，
Hello，
您好，
好
老师。
你好。
はい。你好吗？
好。I would been together. The first one 侯赛德。
present 老师。
OK，6210。
老师，
551222。
Present 老师。
621111。6211。
Present
1218。
yes 老师。
1208。
I'm here, miss.
伊利。
I'm here, miss.
法西木。1213。
Present teacher.
Yes 老师，I'm here. Yes I'm here.
1211。
I'm present. I'm present. I'm present.
6207。
I'm present,
6207。
teacher. I'm present.
1220。
I'm here, miss.
1207。1207。Hello, this one.
Miss, I'm present.
OK。艾特。
I'm here, miss.
1206。1206。1206。1210。Which one is here? 1210。OK。1210。1210。1210。OK。1204。
Present, miss. Present.
，Present 老师。
1205。
Present 老师。
排名。
Present teacher. Present.
6212。 6212。6212。6205。
I'm here, teacher. I'm here.
蕾蕾。阿莫斯。OK。
I'm here, miss.
OK。620602。6203。6204。
Teacher, 老师，
说。6208。Which one? Present, which one? 6206. Maybe next time, okay? We have. You didn't hear. I didn't hear. Which one? 55106。55106。Maybe the second time I will check it because here I can't find you here. 6208。6208。55101。6209。
Present, teacher.
1212。
Present.
Somebody is disturbing us.
1朗1连。No, only Zenbei is not here. Only Zenbei and 6212。
老师，你叫我吗？
Yeah, 1连 present already. Now, this one 6212. Let's go. I guess 6212 is not here. She is not our classmate. She quit because she's always not here. And this one 6208。6208。OK。 What's your idea? I can't see your ID here. I remember you always absent. You always be late. This is not the first time I change your. You want me to change your station? Why are you always be late? You are. Why? Because I remember you. Okay, and today we will learn the area of a plane rate. Okay, the brief discussion of area in section 4.1. But this is not the first time. So this is not the first time. I won't give you a second chance. The area of a plane rate. The area of a plane rate. The brief discussion of area in section 4.1 served to motivate the definition of the definite integral with the lighter notation now firmly established. We use the definite integral to calculate areas of ranges of more and more complicated shapes. As is our practice, we begin with simple cases. And we will consider a rate about the x-axis, like this. Okay. Let y is fx determine a curve in the xy plane. Here, y is fx. And suppose that f is continuous and non-negative on the interval a less than or equal to x. And x less than or equal to b, as in figure 1. Here. Consider reach are bounded by the graphs of y is fx. Here, this is y is fx, x is b, xa, xb, y is 0. We refer to R as the reach under y is fx between xa and xb. Its area, AR, is defined by AR. The area of AR, the area of R we write is AR is equal to this definite integral AB fx dx. We have learned this in section 4.1. I hope you remember it. Area. And now example 1 is find the area of the reach R and y is x4 minus 2x cubed plus 2 between x is minus 1 and x is 2. Here, this is the curve y is x4 minus 2x cubed plus, this is plus 2. Between x is minus 1 and x is 2. Here, this is the reach of R. Reach R. The graph of R is showing in figure 2 a reasonable estimate for the area of R is its base times an average height. We will give the reasonable estimate for the area of R. This means we can calculate by the base. Here the base is 3, right? 3 times the average height. Average height we find maybe is 2. So the reasonable estimate is 6, right? Is 6. And the exact value is not exact value. Now y is x4 minus 2x3 plus 4. This curve is above x-axis, and by a reach above the x-axis, we find AR is equal to AB fx dx. So it's equal to minus 1, 2. This is AR is equal to AB fx dx is equal to minus 1, 2. This x4 minus 2x cubed plus 2 dx. And by the linearity and the parallel, we find any antiderivative. This is x5 over 5 minus x4 over 2 plus 2x. Minus 1, 2. And we x is 2, we find this 32 over 5 minus 16 over 2 plus 4 minus vx is minus 1 is negative 1 over 5 minus 1 over 2 minus 2. The calculator is 5.1. And our estimate is 6. So the calculated value 5.1 is close enough to our estimate 6 to give us confidence in its correctness. We have this one. Example 1. Do you understand this? Example 1. Lower limit. Yes, lower limit is minus 1. Here, lower limit. Maybe you can, Francimo, you can, maybe you can send a message, not this private, 私聊, public, okay? Because You just sent me the question, but other students cannot see the question. They maybe they don't understand what I'm saying. What I am saying, right? If they also can say your message. Maybe other students can consider these questions, and they will know what I'm saying. I am saying, right? 把序幕 and this 120, right? Okay, because we am explaining, maybe they are confused, right? Okay, and the upper limit and the lower limit here. Okay. Here this is we know from this the ridge about the x-axis. Here ridge. This is the ridge. First, you should can graph the ridge R. Graph the ridge R. The ridge is bounded by the graphs y is fx. Give the graphs of R. Here, this is the graph y is fx. Xa, xb. This is between xa, between xb, and y is 0. So this is y is 0, right? Y is 0. And we refer to R as the ridge, and y is fx between A and B. So its area, AR, is given by here, because x is between A and B. So here, the lower limit is A, and the upper limit is B. This ridge is under the curve y is fx. So the integrand here, this is fx. So we write this definite integral as this form. And now this is a concrete example. Here, the curve we have the equation is x4 minus 2x cubed plus 2. And between x is minus 1 and x is 2. This is x is minus 1, x is 2. So this means we have here A. This means the lower limit is minus 1 and the upper limit is 2, because x is between minus 1 and 2. And the integrand fx is x4 minus 2x cubed plus 2. So we calculate the data is 5.1. You understand the lower limit and upper limit? Always the graph will be shown. Always the graph will be shown. Yes. It's the graph. Yeah. Always you should draw a graph. Yeah. I think it's better to draw a graph because it helps you to understand the rate. The rate R helps you to find the lower limit and the upper limit. Which is draw, yeah. If don't, it's okay. If don't, it's okay. This means it helps you to understand the lower limit or to find the lower and upper limit. But if you don't draw the graph, you know how to do it. It's okay. Okay. So I think it's just better to do it. And questions? No. Okay. Here, example 2. Find the area of the ridge are bounded by y is x squared over 3 minus 4. The x-axis, x is minus 2, x is 3. Now I will teach you how to draw the graph. Here, on this one. First, we should draw the graph of the curve y is x squared over 3 minus 4. This is the quadratic. Okay. X1. X0, y is minus 4. X0, y is minus 4. And we y0, we find y is 0. This means x squared over 3 is 4. X squared is 12. We can find x is positive x is positive or negative 2 times the square root of 3. Right? So we have 2 points. This is negative 2 times the square root of 3. This is a positive 2, 3. And here, this is negative. Bounded by this. Here, this is. Here, this goes down for minus 2. Here, give this one. Can't say. Why? Why can't I say? Now, can you say? No, black screen. Black. Why? It's suddenly. Now, can you see? No, okay. Okay. This is y is x squared over 3 minus 4. We find x1, 0, minus 4. Here, this is the curve. Y is x squared over 3 minus 4. The x-axis, x is minus 2 here. X is minus 2 here. Minus 2 is here. Between x is minus 2, minus 2, and x is 3. X is 3. 3. We have found 3 and the square root of 3. Please tell me which one is bigger. These two numbers. This is bigger, right? Because we can square, right? Square. This is 9. This is 12. So 12 is bigger. This means 2 times the square root of 3 is bigger. So 3 is here. This is 3. So the ridge, you can see the ridge. I use another. This is 蓝色的，我们用 here. This is minus 2, 3. Minus 2, 3. Here the ridge. This is the ridge. Right? This is, we say x is minus 2. X is 3. This is x-axis. X-axis. And bounded by y here, this one is y is x squared over 3 minus 4. So this is the rate. And this is find the area. So the area we write is AR. Is equal to AR is equal to, please tell me the lower limit and the upper limit. Quickly. Tell me the lower limit. A lower limit? No. It's not minus 2 times the square root of 3. It's not this one. It's not this number. Here, you see, the ridge is bounded by this curve and x-axis, and x is minus 2. Let's think of again. Please tell me the lower limit. Quickly. It's not minus 2 times the square root of 3. Oh, this is the upper limit. Oh, no. Upper limit is minus 2. I know. Okay, I know. The lower limit is -2, right? And upper limit is 3, right? It's 3. The integrand is x squared over 3 minus 4. This is dx, right? This is dx. This is 2, right? So by linearity, we find an antiderivative. This one we find, please tell me, an antiderivative. Antiderivative, this is 2x square over 9, right? This is minus 4x, not over 3. Here we have the coefficient is, this is 3, so it's x cubed over 9. Three. Right? To calculate x is 3. 3 cubed over 9 minus 12. Minus 8 over 9 plus 8. Let me see the answer. That's right. Oh, this is, oh, sorry. This is, Oh, right. I forgot the negative here. The area, because you know y is x squared over 3 minus 4. This is curve is not upper. Example 1. Example 1. This is the read about the x-axis. So this is lower. It's not above. So we find the area is equal to minus, right? Minus. So it's minus. 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 Here, this is the right answer. The rate R is due in figure 3. Our preliminary estimate for this area is the base is 5, the height is 3, so it's 15. And the exact value is AR. Here is equal to minus 3. Upper limit is 3, lower limit is minus 4. The x squared over 3 minus 4 dx. So it's minus x squared over 3 plus 4 dx. The answer is 145 over 9. We are reassured by the nearness of this is 16.11 to our estimate. Any questions? Exam 2 and question. Yeah, exam 3. Exam 3 is find the area of the reed are bounded by y is x cubed minus 3 x squared minus x plus 3. Here, this is the area of a ridge bounded by the segments bounded by this curve and the segment of the x-axis here, x-axis. Between x is minus 1. Here, this is minus 1. And x is 2. Here, this x is 2. And the line x is 2. And the line x is 2. X is between minus 1 and 2, and the line x is 2. Okay. The ridge R is shaded in pink from this is the ridge R. Ridge R. Note the part of it is above the x-axis. Here, R1 is above the x-axis, and R2 is below. So the areas of these two parts, R1 and R2, must be calculated separately. You can check that the curve crosses the x-axis at minus 1, 1, and 3. You can check this to have the curve like this. Here, this is minus 1, 2. Minus 1, 2. Minus 1, 2. And you can check that the curve crosses the x-axis at minus 1, 1, and 3, and that's AR. AR we write is AR1 plus AR2. AR1 plus AR2. And here, AR, now, okay, now here, AR. AR is equal to AR1 plus AR2. And AR1. AR1, this R1 is bounded by y is x cubed minus 3x squared minus x plus 3 between minus 1 and 1. This tells me AR1 is equal to this definite integral. Here, tell me the lower limit and upper limit. A lower limit minus 1. Upper limit, this is 1. It's 2. No, this is A1. AR1, not AR1. Here, this is AR1. Please tell me the upper limit is not 2. Lower limit is minus 1. Upper limit. Okay. Yes, it's 1. It's 1. Minus 1, this is 1. And the integrand is x cubed minus 3x squared minus x plus 3 dx. So this is AR1. AR2. AR2. Here AR2, the curve is still x cubed minus 3x squared minus x plus 3. It's below x-axis. It's below x-axis, so it's minus. Please tell me the lower limit and the upper limit. Please tell me the lower limit and the upper limit. Lower is 1, upper is 2, right. X cubed minus 3x squared minus x plus 3 dx. Is equal to here we calculate this two definite integrals. Two definite integrals. Minus 1, 1, x cubed minus 3x squared minus x plus 3. The first one is 4, and the second is equal to minus 7 over 4. Minus 7 over 4. So it's 23 over 4. 23 over 4. Now, note that we could have written this area as one integral using the absolute. We can use the absolute value symbol. We can write in two integrals. We can also write it as one integral using the absolute value symbol. We write AR is equal to here. The lower limit is minus 1. The upper limit is 2. Because AR2 is just the minus. This curve is below the x-axis. So we can write this minus 1, the absolute value of x cubed minus 3x squared minus x plus 3 dx. And but this is no real simplification since in order to evaluate this integral, we would have to split it into two parts, just as we did above. This means we will write here minus 2 to 2, we write is minus 2 to 1. This is x cubed minus 3x squared minus x plus 3 dx. Plus this 1, 2. This x cubed minus 3x squared minus x plus 3 dx. And it's equal to here minus 2 to 1. We know this is the x. This curve is about the x-axis. So this means this function is positive. So we can omit this absolute value plus 3 dx and plus 1 to 2. And the in the interval 1, 2, we find this curve is below the x-axis. So the absolute value, because the value of this part is negative, so the absolute value we find is minus x cubed minus 3x squared minus x plus 3. dx. So we can find the other side. Any questions for exam 3? No? Okay. Okay. So a helpful way of thinking for simple ranges of the type considered above is quite easy to write down the correct integral. When we consider more complicated ranges, for example, ranges between two curves, the task of selecting the right interval is more difficult. However, there is a way of thinking that can be very helpful. It goes back to the definition of area and of the definite integral. Here is in 5 steps. Step 1, sketch the rate. Step 2, okay, step 1. This just we have this be very helpful. Sketch the rate is very helpful. Sketch the rate and slice it into thin pieces or strips. Label a typical piece. Text or typical. Approximate the area of this typical piece as if it were a rectangle, and add up the approximations to the areas of the pieces. Take the limit as the width of the pieces approaches 0, thus getting a definite integral. Okay, and we have a little break, and then I will explain these 5 steps because I think now you are confused with these 5 steps and have a rest, and I will explain it in detail. Okay, have a break. Hello. This is the helper way of thinking. First, we just cast the ridge and slice it into some pieces and approximate of the area of this typical piece as if it were a rectangle. Then we add up the approximations to the areas of the pieces. And step 5 is take the limit as the width of the pieces approaches 0, thus getting a definite integral here. Okay, and now we will use this 5 steps to calculate the area of this ridge. This ridge. This is example 4. Here, they set up the integral for the area of the ridge, and y is 1 plus the square root of x between x0 and x is 4. Here, first, we just sketch the curve. Y is 1 plus square root of x. See? X is 0, y is 1. Y is 1 plus the square root of x. Between x0, x is 4. X0 and x4. So this is the ridge. The first step we have sketched the ridge, and the second step we slice here. The second step we slice it into thin pieces, like this. Slice it. Okay, and this is a label a typical piece. This is a 典型的。Let me just say. Oh, this is a typical. We choose a typical, label a typical piece. Typical. For example, this is a typical. This is a typical piece, right? This is a typical piece. This is a typical piece. You can choose any typical piece. And the third step is approximate area of typical piece. Okay, and with the base, this means as it were a rectangle. As it a rectangle. As this is a rectangle. If this is a rectangle, we write like this. Here. This is the typical piece. This is a rectangle. And so the base is delta xi. The base is delta xi. Here is the base delta xi. And the height we will choose here at this point. This is xi. This is the curve. Y is 1 plus the square root x. So this is xi. We have this point is y. Yi is equal to 1 plus the square root of xi. So this is 1 plus the square root of xi. This is the height. Height of 1 plus the square root of xi. And then we have the area of the rectangle. We write this is equal to the base is delta xi. And the height we write is 1 plus this one. So this is the area of the rectangle. And we approximate area of a typical piece. We write is delta ai. Delta ai is equal to 1 plus the square root of xi times delta xi. Delta xi. 1 plus the square root of xi times delta xi. This is we just find is about. It's not the same. Approximate area of typical piece by the area of rectangle. So we have delta ai. And then the first step is add up the approximations to the areas of pieces. Yes. And the first is add up. This means we add up this I from 1 to n, delta ai. This add up I from 1 to n. 1 plus the square root of xi times delta xi. This is the first step. And the last step is take limit. Take limit. This means we like to take limit. Take the limit as the width of the pieces approaches 0. This means delta xi. Every delta xi approaches 0. And thus getting a definite integral. We have to take limit. So we have the area of the ridge. We write is A. This is here is between x0 and x4. So the lower limit is 0. Upper limit is 4. It's 1 plus the square root of x. This is dx. Here, this is the area of this ridge. And we calculate this is the x plus this is the x, the power is 3 over 2 over 3 over 2. 0, 4, right? 0, 4. Zero, 4. So we calculate this. And here is the step. And then we read it again. Once we understand this 5-step procedure, we can abbreviate it to 3. First is slice. Second, approximate. Third, integrate. Finger of the word, integrate as incorporating 2 steps. Add the areas of the pieces And 2 is take the limit as the piecewise tends to 0. In this process, sigma delta x transforms into sigma transforms into integral delta x transforms into dx as we take the limit. And the figure 6 gives the abbreviated form for the same problem. This first we slice. We have delta x. Slice this delta x, and they approximate. Delta a is about 1 plus the square root of x times delta x times dx, and then we integrate the a. We have 2 steps. First is approximate, and the second we integrate. Is we find the x. The smallest number is 0, and the biggest is 1. So we find the lower limit is 0, upper limit is 4, because here the range is between 0 and 4, between x0 and x4. So 0 for 1 plus the square root of x dx. And then we have the answer. Do you understand it? Maybe I will give you more examples to understand it. Oh, here this is just a range. This range is simple, and we will face with range between 2 curves. Here, this is a complex range. When consider curves, y is fx, y is gx. With gx is less than or equal to fx on x is between a and b. They determine the range shown in figure 7. We use the slice, approximate, integrate method to find its area. Be sure to note that fx minus gx gives the correct height for the thin slice, even when the graph of g goes below the x-axis. In this case, gx is negative, so subtracting gx is the same as adding a positive number. You can check that fx minus gx also gives the correct height, even when both f and g are negative. Here, we have, this is, we choose any, which you can slice and choose any typical piece. For example, I choose this one. It's not this one. I just choose this piece. And this piece, I will approximate the area of this piece by the area of a rectangle. So I will find the base of a rectangle. The base, we write it always. The base is always delta x. And the height we write is this one. This is the height. So the height is here. We have the curve. The equation is y is fx. So, and this curve, we have equation is y is gx. So the height is fx minus gx times the base. Times the base is delta x. So this is approximates the area of this piece. Delta a is about fx minus gx times delta x. And then integrate. We find a is integrate because this range is between a and b. So integrate, this is a, b, this is fx minus gx dx. Here, we find the area of this range. Do you notice? Hello? Do you understand this? This is a ridge between two curves. Okay, and give you an example. We will explain it together. I will explain it, and this means we will do it together. Okay. This is find the area of the ridge between the curves y is x4 and y is 2x minus x squared. And we start by finding where the two curves intersect. And the first step, we should draw the graph of y's. Here, this is the graph of y's x4. And the curve y is 2x minus x squared. Y is 2x minus x squared. We start by finding where the two curves intersect. We find intersect at the origin. To do this, we need to solve. This means we want to find the intersection. We will solve this equation. 2x minus x squared is equal to, this is x4. This is the first degree equation, which would usually be difficult to solve. However, we can get to the case. Now here, we can get x0. We try this point 0, and we think another point x is 1, because these 2 points are rather obvious solutions. Right? So 0, 0, 0. This is 1, 1. Through intersection. Our sketch of the ridge, together with the appropriate approximation and the corresponding integral, is shown in figure 8. Here. This is y is 2x minus x squared. And here is y is x. Here, this curve is y is x4. Y is x4. And the intersection, the ridge, here, this is the ridge. This ridge. Find the area of this ridge. In figure 8. So first, we will choose a slice and choose a typical piece. Choose a typical piece. Maybe I will give like this. This is y is x4. Here, this is y is 2x minus x squared. This is the curve. So here, this is the rate. This is the rate. And we will choose a typical piece. I use another. This is the color blue. Okay. We choose another. Choose here. We choose a piece. Choose a piece. If I write this point is x, because the base is always delta x. So this one we find is x plus delta x. And the base, here the base is delta x. And the height, we find we use a rectangle to approximate this piece. So the height is equal to, oh, sorry, maybe this, I have this is a little confused if I have like this one. Okay, I choose a piece here. Here. X. This x, the x plus delta x. X plus delta x. X plus delta x. And so the rectangle, this is the rectangle. This is a rectangle. And the base is delta x. The base is delta x. The height is equal to here, this one. This is the height. This is the height. This is the height. So the height is the y coordinate of this point minus the y coordinate of this point. And the curve, this is y is 2x minus x squared. So the height is equal to 2x minus x squared minus the height of this point, the y coordinate of this point. This point on the curve, y is x4. So it's minus x4 times the delta x. This means we have the approximation is equal to 2x minus x squared minus x4 times delta x. And we integrate because the rate x is from 0 to this is 1 to 1, right? 0, 1. This is 2x minus x squared minus x power 4. This is delta x transform into dx. So we have this is the area of this rate. We have the x squared minus 1 over 3 x cubed minus 1 over 5 x power 5. 0, 1. And we calculate it. Any questions? Hello? No, you understand all this? Okay, how about the other students? No. Everyone understand this? Okay. Here. Exam 6 is more difficult than exam 1. Here, there's a horizontal slicing. We say this is the vertical slicing. Vertical. We choose a piece vertical slicing. And this is horizontal slicing. Exam 6 is find the area of the ridge between the parabola y square is 4x and the line 4x minus 3y is 4. Okay, and we will need the points of intersection of these two curves. The y coordinates of these points can be found by writing the second equation as right. 4 is 3x is 4x is 3y plus 4, and this is equal to y square, right? Y square. So we solve y, the point is 1 and minus 1. We find y is 4. Y is 4. We have 3x is 4x is 3 times 4 plus 4. We have x is a minus 1. X is 4. We solve x is 4. And y is what? Y is minus 1. We find 4x is equal to minus 3 plus 4 is equal to 1. We have x is equal to 1 over 4. Right? 1 over 4. The x is 4. X is 4. This x is 1 over 4. So we conclude that the points of intersection is 4, 4, and 1 over 4 minus 1. And we should give the curve, the parabola, this is y square is 4x here. This is the y square is 4x. Here is parabola, y square is 4x. And the line, this is the line. 4x minus 3y is 4. This is the line. So the ridge, here is the ridge. Okay, here is the ridge. A ridge between the curves is shown in pink line. This is the ridge. And we find the area of this ridge. Here is the ridge. Now we can slice the ridge vertically, just like example 5. What we have to do in example 5. We're slicing this ridge vertically. Maybe I'll give you this ridge. Oh, okay. It's ridge. And we face a parabola because the lower boundary consists of two different curves. Slice at the extreme left extend from the lower branch of the parabola to its upper branch. For the rest of the ridge, slices extend from the line to the parabola. This means run like this. We slice at the extreme left. Here, this is the extreme left. This is right. Extend from the lower branch of the parabola to its upper branch. Here, this is Here, this is y square is 4x. If we slice it at the extreme left, okay, we find this slice thin piece, and when the base is always delta x. The base, we find the area of the rectangle. The base is delta x, and the height we find. This means from the lower branch of the parabola to its upper branch. So the height is here. Is the point with the y coordinate. The point we find is on the parabola, and this y coordinate, and we find this point is still on the curve y square is 4x. So this height is equal to the upper branch minus lower branch, right? Upper minus lower. And if we for the rest of the ridge, this means if we slice like this, here we have a thin piece, and we can find the base is still delta x, but the height is equal to the y coordinate on the parabola minus the y coordinate of the point on the straight line. This 4x minus 3y is 4. Okay. This means to solve the problem with vertical slices requires that we first split our ridge into two parts. This is just another this. Into two parts. Okay, we split our ridge into two parts, set up an integral for each part, and then evaluate both integrals. Set up an integral for each part. This means we set up an integral for each part. Here, okay, we write this as AR1 plus AR2. AR1 plus AR2. And here AR1. We write for AR1, we write delta A1 approximate by this base is still delta x, but the height is the upper branch. Upper right, we have the y is to the square root x. Y is positive, and minus the lower branch, because y square is 4x. We can find y is equal to positive negative to the square root of x. So this point we have the y coordinate is minus to the square root of x. This is delta A1. And A1 we integrate. Because this is A1, this is A2. So here integrate, we will find the x, the interval, x on the interval. Here the intersection is 1/4 minus 1. This means x is 1/4. X is 1/4. So the lower limit is 0 here. The smallest number of x, 0. The upper limit is just here. At this point, we have the x coordinate is 1/4. This is 2x minus 2x dx. Is A1. And A2, we find A2 this first we should also find delta A2 approximate by this rectangle, like this rectangle. We have the base is still delta x, and the height is the y coordinate of this point minus the y coordinate of this point. The y coordinate is the square root x, and this y coordinate we find is 3y is equal to 4x minus 4. So it's equal to 4x minus 4 over 3. So we find A2 integrate. Integrate, we find the lower limit. Here, this is 1 over 4. And the upper limit, this is upper limit. Here, 1 over 4. This upper limit. This point, we find the coordinate is 4, 4. So the biggest number of x is 4. And this is 2x minus 4x minus 4 over 3. Times dx transforms into dx. And then we have a is equal to a1 plus a2. Okay, this means we use the slicing vertically. We should split our reach into 2 parts. Do you understand this? If no, I think it's okay. Maybe you don't understand, or you don't understand, right? Only me understand what I'm saying. Okay, this is just one method, and I will introduce another method is slicing horizontally, not like this. Okay, like this. So a far better approach is to slice the ridge horizontally as shown in Figure 10. Thus, using y greater than x as the integration variable, we will change the integration variable we use. Using y greater than x as the integration variable. Note that horizontal slices always go from the parabola to the line. This is at the left to the line at the right. The length of such a slice is larger x value minus the smaller x value. This means we choose slice it horizontally. And we approximate this thin slice, thin piece by a rectangle. Here we write this delta y. The base is delta y. The height, this means always, note that horizontal slices always go from the parabola. Here, parabola to the left, at the left, to the line, at the right, to the line at the right, at the right. So from y square is 4x, we can find x is y square over 4. So the length of this straight line, the length, and this is 4x minus 3y is 4. We have x is equal to 1 over 4, 3y plus 4. So the length is the x coordinate of this point minus this one. So we have delta A approximate by a rectangle. The rectangle, the base is delta y, and the height is 3y plus 4 over 4 minus y squared over 4. And then we integrate from y. We find the integration variable is y, so we find the smaller value of y is minus 1 from this point to this point. So the biggest y value is 4. This is 3 plus 4 over 4 minus y squared over 4. Delta y we write is dy. And then we calculate this. We calculate this definite integral. We find this area. Find the area of this ridge. Just the y is available. Okay, we can use linearity. We can use power law to solve this definite integral. Any questions for this? No. No. No questions. No. I understand this. Okay. Here this is answer. Minus 1 4 3y plus 4 minus y squared over 4 dy is equal to this one 1 over 4. We have the value is 5.21. There are 2 items to note. First, the integrand resulting from a horizontal slicing involves y not x. And 2, to get the integrand, solve both equations for x and subtract the smaller x value from the larger. No? No questions. Okay. Okay, maybe we have the rest time we have some exercise. It's 11, 12, 13, 14. I think this part is these questions these problems are more are easier than what we have learned. This is easier than example 6. This one. In problems 11 to 28, this first, okay, you should sketch the ridge bounded by the graph of the given equations, and show a typical slice. Approximate its area, set up an integral, and calculate the area of the ridge. This step is needed. Okay, you just sketch the ridge, show a typical slice, approximate its area, set up an integral, and calculate the area of the ridge. Please have a try, and we will explain to next Tuesday. Next Tuesday. 星期二. Okay, now you just try to finish the Hello, bye bye, everyone. Bye bye. I hope you can review this is the contents we have learned. Okay, from next week we will review. Okay, we will review the contents. Okay, and please do 11, 12, 13, 14 by yourself. And the next class we will explain. Okay, bye bye. No, not homework. Not homework. Bye bye.
What's going on?
Also